So I have 45 minutes. I will try to stick to it. The target is taking you from nothing to a full graph database. I will really try to get all of you to a full data graph database at the end. Please stay with me. Don't run away. Don't be scared. It doesn't hurt. So about myself really quickly. I'm Gianni Ceresa. I'm from Switzerland. I work with business analytics, CPM, data warehousing, and just data for more than 10 years. I'm an ACE director. I blog from time to time. I also spend way too much time on forums. Oracle just changed all the forums like 2 days ago. It's a big mess, but I'm still there and trying to help the community and just support each other. And now let's dive directly into the topic. First, I always forget this slide about the ACE program. You probably already heard this part because many ACEs already spoke today. The ACE program has 3 different levels. It's all about sharing knowledge with the community and supporting the community. Feel free to visit the link to find out more about the program. If you want to nominate somebody or yourself, go to that other link. You will find all the details on how you can nominate somebody for the program. Read the webpage, you find all the details. I will not really spend hours telling you about it now. Directly into the topic, what is a graph and what it looks like in Oracle? So where do we find the graphs in Oracle? First thing first, what a graph is not. I already had sessions where people were expecting what a graph isn't, so I prefer to say it directly. These are not graphs. These things are charts. I know that in many languages they are called graphs, and with the translation we all call them graphs, but I always try to force myself to call those things charts. It's a bar chart, it's a line chart, it's a pie chart. These are not graphs. So what is a graph? A property graph database is extremely simple. Only 2 different kinds of objects, not more than 2. You have the round vertex, also called node. You can use both names independently. And then you have the lines, arrows, they are called edge. You take a bunch of them, you shake a little bit, and you get a property graph. It's really as simple as that. Let's see how a graph can look like. So this is a visualization of a super simple small property graph. So you see there are the rounds, there are the lines connecting things. Starting from the vertex, every single vertex has an ID. Just because we need to identify every single object in a unique way, that's a normal thing to have a unique ID. Then a vertex can have a label. In this example, they don't have a label, but a label for a vertex is just a way to classify it. It qualifies the vertex. For example, if a vertex is a person, the label will be person or customer. Another label could be product or it could be country or something like that. It just qualify what is this node about, what it does it represent. And then because it's called a property graph, we also have properties. So every single vertex can have, it's not a must, it can have properties. Properties, it's super simple, it's key values. It's always one key equal one value. But the list of key values, it's undefined. It can be from 0, so no properties, up to as many as you want, a few thousand. And the interesting thing is that every single vertex is totally independent. One vertex can have 1 property. The vertex next to it can have 10 properties, and the other one next to these 2 can have 2,000 properties. So there is not a direct link between them. The number of properties per vertex is totally free. So the other component of the graph, the edges, here again we have a unique ID. We need to be able to once again identify every single edge. You will generally never use the edge ID. It's really just a technical thing, let's say. Then edges have labels, and here the label it's kind of mandatory because the label qualifies the relationship. It's generally an action because it really needs to qualify how 2 nodes are connected. For example, created knows or lives in or is part of. So it's always something that really defines the relationship between 2 different nodes. Then edges can have properties. Here again, the properties is key values. Super simple, 1 key equal one value. But the number of key values is again totally free, from no key properties to few thousands, as many as you want. And once again, every single edge as totally independent can have different number of properties, one edge compared to the other one. And then there is, most of the time, I will say in general, edges are directed. So you see, it's not just a line, it's really an arrow that points somewhere. That's really a directed edge. In this case, we can see on the left side, we have Marco knows Vadas. Because there is an edge with an arrow, it means that Vadas in this graph does not know Marco. So it's not bidirectional, it's really a single direction thing. This is what a graph is. Just to give you an idea, probably all of you are familiar with relational databases. So how does a relational database compare to a graph database? This is really a super high level generic comparison between the two. Database, you have a bunch of tables. Tables have columns, and the tables contain rows. Tables can have joins. The graph is nodes and edges. This means that when you have, for example, rows in your tables, every single row in your database has exactly the same columns. In a given table, every row has the same number of columns. And the join is not at the row level, it's at the table level. So your row inherited the join defined by the join between tables. On the graph side, it's fully free. So what is a row in a table on one side can become one node on the other side. And because the number of properties is dynamic, you don't have the same constraint as every single row of the same table has the same number of columns, but it's every single node, has a totally independent and free number of properties. And then when you have, for example, mapping table, like the one on the top on the left side, it just map one row from the left table to the one row to the right table. This one can become an edge because the edge can have properties as well. So the edge connects two nodes. So it's the right place to say, this is the mapping relationship between these two nodes. So this is a way that you can imagine how you can translate a relational database to a property graph. Some examples of graph. This is not me painting in the weekend. This is just a small graph fully visualized. When we focus a bit more in, this is a data lineage graph. So it just tells me, for example, it is based on an analytical platform. It tells me this database column is used by all these dashboards. These dashboards can be accessed by these roles. So it's super useful for impact analysis. If I need to change a database column, what am I going to destroy if I change this column without telling anybody? Well, in this case, thanks to the graph, I can go from few thousand objects, like 45,000 nodes. I can get just a short list of 85 objects that I will impact if I change a database column. So the graph in seconds tell me all the relationship between objects. Another example, fraud detection. If I want to clean up some money, so money laundering, I will just like fake selling things between fake companies and make the money move around. When it come back, it's clean. It doesn't work like that, but that's not the topic of the talk. But I mean, you clearly see there are circles, there are loops. These kind of loops in a graph are super simple to detect. While in a relational database, it's more complex because the length of the loop, so how many steps you have, it's fully dynamic. The graph doesn't care, it will easily detect all the loops, even if it's a 2-steps loops or a 2,000 steps loops. Another example, something we're not doing anymore, when you just travel. What is the shortest way to travel from one city to another one? What is the cheapest one? What is the fastest one? What is the most ecological one? If you have a graph with all the kind of connection, like all the flights, all the train, timetable, all those things, you can easily find out how you can go from one town to another one, finding various kind of patterns, find various kind of path based on the condition that you set. And now, how does a graph look like in Oracle, where it is? So Oracle developed what they call PGX. It's the Oracle Property Graph Server. It's extremely simple. Let's say it's a black box. Let's take it as such. It's really just a graph engine. It doesn't do anything else than being smart for graphs. It works in memory. And Oracle decided to not lose time replicating storage management and user interface development, all those things. For storing graphs, they just say, let's use other existing tools. So PGX can store a graph, or actually can use a graph that is stored on a file system as a file, or it can use the Oracle database as a source for a graph, or it can also use big data solution or NoSQL databases. So they just reuse existing storage layers and storage solutions. For the graphical interface, once again, they say, we give you the engine. It's up to you to decide where you want to use it. So PGX speak REST. PGX has a full REST interface, and you can interact with PGX from any kind of language that can use a web service. So there is not a proper graphical interface into PGX, but you can develop one in JavaScript, in Java, in Python. You can use whatever you want. You can really interact with graphs easily. Let's go straight to building a first property graph. And here we will see if my environment will crash or not. So I'm just using a notebook because it's easier to run code and keep it documented. You don't need a notebook to do graphs. I just use it because I prefer it that way. So I use Jupyter. And because Jupyter speaks Python mainly, I just use a package, jpipe, that interacts from Python to Java. Because the full API, it's available in Java. So I use the Java client of the graph in Oracle to just say, this is how I interact with my graph. It makes my life easier than calling the web service by hand myself. Let's say it's the lazy way, but it's an official client that you find on the Oracle website. You can download the Java client. So I first start by importing the packages that I need. I need to connect to my Java virtual machine in the background. And now I'm going to connect to a graph server, so PGX. PGX has really act as a server. So I connect to it saying, this is the URL, this is the name of my session, create session. And here I'm connecting, and if I'm lucky, there I am, I'm connected. So now let's build a graph. Building a graph is super simple. As you can see, I start creating a builder, which is just defining a new graph builder, and then it's calling a bunch of add vertex and add edge. Add vertex, the first parameter is the ID of the vertex. I can add labels, I can add properties, and the edges are the three parameters. It's the edge ID, source node, target node. And again, I can set label, I can set properties. So it's really super, super simple. It just add vertex, add edge. And once I did these things, I have a builder which is ready. And now I can just say, hey, graph, can you please build my builder and give me back a graph? And if I'm lucky, here I am. I have a graph. It's called unmade01, n equal 8. There are 8 nodes in my graph. E equal 9. There are 9 edges. And created, this is a timestamp, just to know when I created this thing. To prove you that I'm not cheating, I'm just going to visualize it. So I use some Python code to display a graph. This is just like a shortcut to show you something. And this is the graph that I just created. Here it is. So talking about Pete, Pete was speaking earlier today. So there is me. Pete is a friend of mine. Pete lives in Netherlands. For me, I live in Switzerland. Both of Netherlands and Switzerland are part of Europe. Europe is part of the world. And I'm actually presenting this session at this event, which is located as well worldwide because it's fully virtual. So as you saw, I just call a bunch of add node, add vertex, add edge, and there I am. I have a graph. It's super, super simple. That's not how you will create graph. Don't worry, you will never, ever, ever create graph like that. Imagine having few thousand objects in your graph. You will write few thousand times add vertex, blah, 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 add edge, blah, 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 blah. Nope, not at all. So you can do it by hand, and you generally do this one just to prove some concepts. Like when you want to try something super quickly, you just make up a fake graph with few nodes, and there you go. Otherwise, you will never, ever do that like that. So back to the point. Let's talk about how you can build a property graph in PGX, but storing it in the Oracle database. So first of all, just from an architecture point of view, when we use the graph, there is the 3-tier approach, which is Oracle database, a storage layer. On top of it, we have PGX running as a server. It's full in memory. It gives me the power of graph engine. And then there is the client. So it's 3 layers, the client, PGX server, the database. This is one architecture. And there is another one, an alternative one, which is called the 2-tier one, which is just the client, so me doing the queries, and the database. The Oracle database can understand PGQL queries. PGQL is the property graph query language. It's like SQL, but for graphs. And Oracle developed a translating interface that say you can send a PGQL query to your database and you don't need PGX as the graph engine. This can be useful for some cases where where your graph is too big to fit in memory, for example, or when you just don't need to get the graph in memory because you don't need the fancy functionality of graphs. You just want to quickly run a query in your graph. You just say, hey, I go to my database directly. It's a shortcut. So when you want to create a graph, there are multiple ways to get there. First one could be from your database tables, which are the source table, could be your data warehouse, for example, or all your sales, or your customer, or your employees data. And you can say, take all those information and load a graph directly in PGX server from this one. This is a new feature that has been added only a few months ago. So it's still not really used so far. It's still a unknown way of doing things. You just say, from my source data, I go straight to the PGX server. And then there is the longer and oldest path. So the standard way of doing it till a few months ago, which is still the most common one, I will say. You first take your source data, you store them into a property graph schema, still in your database. So it's just a way to store the graph in a predefined way in your database. And then from the property graph schema, you say, and now I load into PGX. So it's a kind of a two-steps movement. Say from source till the property graph schema, from schema to PGX, 2 steps. And these 2 steps is what we are going to do today. So right now, in the next, I guess, 20 minutes, kind of, not 30 minutes, sorry, I'm going to do the 2 steps way. First, creating the graph schema and then loading it and using it. How do you create the graph schema? You need an Oracle database, quite obvious. It must be a 12C release 2 or newer. So there are quite many releases that exist that match with it. One important thing, you need the extended data types. By default, varchar are 4,000. With extended data types, varchar go up to 32,000 something. So you need to enable extended data types. And then in your database, there is a package that exists by default. It's the OPG APIs. And you call the createPG method on it. You give it a graph name. The other parameters, you find them in the doc. It's the number of the parallel process, the number of partitions, and some table space options. You call this thing, and there you go. You have a graph in your database. The graph schema, what is called graph schema, is just a bunch of tables. I was expecting something fancy and super exotic at the beginning, and I got tables, and I was quite disappointed. It's just that Oracle has defined a standard layout, a standard format structure of tables, and your graph fits into those format of tables. The fixed format is just because PGX has to be able to read those tables in an automated way. So you cannot say, I store my graph in whichever format I want. You have to stick to the format that Oracle gives you. The table that you have, it's actually 6 tables. They added one a few months ago. It was 5 before. The name is the graph name that you gave and the suffix. So you have the $G, it's where you store the edges. You have the $GT, officially it's called graph skeleton. It's just the edges without all the properties. So you don't worry about it. There is a trigger that when you insert into $G, it automatically do the job for the $GT. So don't worry about $GT. $VT, where you store the vertices. And then you have a $VD. This is the new one, so it doesn't have an official name so far. I couldn't find it. Again, don't worry about it. There is a trigger that when you enter into $VT, it will automatically populate the VD one. The IT and SS no need to care about them. You will never use them. They are documented. Most of them, it's for future references and future usage. You will never ever go there. So forget about those. The 2 most important are the G for edges, $VT for the vertices. How those tables look like? It's extremely simple. It's just a bunch of columns. And you will easily understand why it's just a number of fixed columns. I told you at the beginning it was an undefined number of properties. A vertex, for example, can have a 0 or 2000 properties. So the only way to store a dynamic number of properties in a database, it's not to store in columns, but to store in rows. So the VT $ table is just a by row storage. The columns are VID, vertex ID, it's a number that identifies the vertex. VL, it will contain the vertex label if you have one. KTV, VNVT. So if you look at the K is the key, T is for type, and the V, VNVT is the value. Key values, you remember properties are key values. So K is the key, T is just to say which type of data it contains, if it's a varchar, a date, or a number. And then because you can store any kind of information as a value, there are 3 columns. The V is a string one, it's a varchar, the VN is a number, and the VT is a timestamp. So you can store any kind of type of information. You can see at the bottom of the screen a super simple example. The vertex 47, so the VID is 47, name is key, age is K, name is the key and going to K, age is a key and going to K, birth date is a key and going to K. The value, Matthew, 47, 1969, 11, 04, blah, blah, blah. Those things are values, and based on the type, they go into V, VN, VT. And the column T, this is just a value. It's a coded reference. When it's a string, it's 1. When it's a number, it's 2. When it's a date, it's 5. Those one you find them in the doc. In the doc, there's a little table that gives you the types for every single type. Edges, quite the same thing. Once again, we store everything by row because an edge can have from 0 to 2000 properties or even more. Columns, extremely similar. EID, edge ID, S, VID, D, VID, source, vertex ID, destination, vertex ID. One edge connects different nodes. So you just say, this edge, go from this one till this one. It's just there. And then EL, edge label, KT, V, VNVT, same thing as the vertices. So they're really a super simple tables with a strict defined format. Do not touch those tables. Do not change the columns. Do not add new columns. What you can do is messing around with partitions if you really want. You can mess around with indexes if you want, but do not touch the structure of the table, please. Or you are just not having a graph anymore. You just have tables. So this is the list of the value for the T, for the type. So as I said, 1 is string, 2 and 3 and 4, it's for numbers, 5 is a date, and so on. So they are in the doc, no need to know them. Oh, Google the doc, you will find this mapping if you need it. It's there, it's simple. So because there are the 3 kind of columns, V, V, and VT, if you want to have a full indexed, if you want to fully index your information, you can also store a copy of the number and a copy of the date into the V column. So when you have a number, you enter a 2-char of this number into V and the number itself into VN, and so on with the dates. That's up to you. It's not mandatory. It's just like a shortcut to have a full indexing of your things. Now let's look at an example. I still have 20 minutes to go from nothing up to a graph. And my graph will be based on sales history. Everybody knows SH. It's one of the universally known demo schemas that you have with Oracle. It's one of the simple schemas. It's just a small shop. You have customers, you have orders, you have products, and things like that. Let's look at a simplified version. We just look at customers, countries, products, and the orders that the customers are doing on products. So how do we model this thing? How can we do a graph with these informations? Well, there are a few questions that you need to find. First one, which nodes to create? So what is a node in this kind of situation? With this requirement, I need to model these 4 tables as a graph. What are nodes? Once I found out what are nodes, so what will be the IDs? What will be the labels? What will be the properties? And once that's done, oh, what is an edge? And once I know what is an edge, what is the edge ID? What are the labels? What are the properties? If you answer these questions, you have a graph. For example, we could say that one table, one node, join between tables equal edges. So 4 tables at the beginning. Let's just say that I have 4 nodes. One node will be a country, one node will be a customer, one node will be an order, one node a product, and so on. Is it a graph? Yes. Is it valid? Yes. Is it the right one? It's not wrong. What about this one? If I take out country as a node and I say a customer in the end can only live in one single place at a given point in time. So I can put the country as a property of the customer. Is it a graph? Yes. Is it valid? Yes. Is it the right one? Once again, it's not wrong. What about this? I could just say that I have a node for the customer, country is still a property, a node for the order, and the product of the order are just properties. It works. Again, it's a graph. But what about this one? I have country being a node, I have the customer being a node, and I have a product being a node. And the order become an edge. So a relationship between a customer and a product is my order. And it has properties as the quantity, the amount, and the order date, or the order number. And then if, as a customer, I live in a country, but I also know the state where I live in a more precise way, I could say that the state, I attach it to the edge that connects the customer to the country. That's a graph again. So let's implement this one. Let's do this graph for real. And here is where we switch back to the notebook. So this is what we are about to create. The first thing to do, so just to say, I'm not cheating. I had to run all those queries because I installed the last version of Graph Server, and it's a bit slower than expected. It will take 20 minutes to execute everything, and I don't have those 20 minutes to wait for the system to run. So I run everything right before to connect to this presentation. I connect to my database. I use CX Oracle, I connect to it. I call the create PG. So I'm creating my graph, I call it my sales. And then I just do a query to find out if you create the tables. Yes. After creating the graph, I see that I have 6 tables. And you see the G $, VT $. So it's really the tables representing the graph. So now let's go to the sources. I have to find the IDs first. Do I have in the source an ID which I can use as a node ID? Well, I thought about using the primary key of the tables. Problem is there are overlaps. For example, I can see that the customer ID go from 1 to 104,000. The problem is that this range contains the ID of product and country. So a clean solution would be, let's use a sequence. If I use a sequence, I'm sure to have a unique ID. But I'm a bit lazy, so I just take a workaround. Let's add an offset. If I say customer, I keep it as such. Product, I always add 200,000. Country, I always add 300,000. All of a sudden, my primary key of my source table give me now unique IDs. Node IDs found, there they are. So let's create the nodes. Because I told you that you have to enter things by row and not by column, all the job is about doing a non-pivot. I have to take the columns, which are in the tables, and turn them into rows. So I took the super simple way of select union all, union all, union all. And in this case, you see I'm taking the countries, for example, and I'm creating various lines, various rows for the same node. For example, you say create one line with a property label. I create one line with the property source ID. I create one line with the ISO code. I create one line with the property name. So these 4 lines, the first 4, are the same exact node. You see the VID doesn't change. The VL doesn't change. I'm just storing properties by row. And once I have these lines, these rows, I just do an insert into my VT $ table. As simple as that. I mean, it's a database table. There is nothing fancy to enter data inside. It's just a table. So insert into, pure SQL, nothing else. Once I'm done with my countries, same thing for the products. Take the products, turn the columns into rows. Once the unpivot is done, just insert into, as simple as that. Customer, same deal. I said the only thing to pay attention at is because we store by rows, if a property doesn't exist, it makes no sense to create an empty row. I mean, when you store by columns, you have a single row representing your customer, while the column will be null. In the graph, it makes no sense to store the null. Don't store anything. The property does not exist. As simple as that. That's why sometimes you have to add the where it's not null to not generate empty rows. And once I did the full job, I have all my nodes. If I query my $VT table, I do a count by label. I see that I have 23 countries inside. I have a 500,000 customer, and I have 72 products. So I just created all those nodes. It's 55,500 or maybe 600. Let's round a bit. I have that amount of nodes. It's a super small graph, but I just created all my nodes. Time to create the edges. I can also just query about the properties. It's a table, so I can just do SQL again. And here I can see, for example, all the properties that exist for every single kind of node. And you see that there are not always the same number. For example, this is the one that is often null. I don't know the marital status of everybody, so when I don't know it, I just don't create it. So time for the edges. I have two edges. I have the customer living in a country, and I have the customer ordering a product. The thing is, in this case, I don't have a single ID that I can use because the order table does not contain a primary key for every single line. It's the ID is defined by customer, product, order date, and so on. So I have no ID in this case to just make up a fake edge ID. So I have to use a sequence. I create my sequence, and then the job is right as before, turn columns into rows. The customer living in a country, I have to generate the one row for each edge. It can have a property, which is a state province, which can have a value or not. And then I use the sequence to give an edge ID. So here you can see that I'm using the EID sequence next val to say, this is now my edge ID, while the rest of the values, I just take them from the table. The second kind of edge I need is the buys. I have a customer buying a product. So in this case, because I have to do a pivot of multiple properties, I say I will just create a temporary table so I can store the edge ID from my sequence there inside, and then do my unpivot and then do the job easily. This is really super simple SQL. I'm just doing an unpivot with a sequence. So I aggregate the lines to have aggregated lines when possible. I use my sequence, and I do the same job as before: union all, union all, union all. Take the columns, unpivot into rows. That's the main job you need when you are populating a graph, doing unpivot all the time. The result I will insert in my graph, in my table, will be this one. For example, you see the first three rows, it's one single edge, because it's property amount, property order date, property quantity. So in this case, it's quantity 1, order date was quite a long time ago, and the amount was 1,232 and 16 cents. And I do the same thing for all the other orders. And insert into $G$ for the edges, just as simple as before. And then I'm cleaning up a bit, so I drop the temporary table, I drop the sequence, I don't need them anymore. And now I can check how many edges I created. On the $G$ table, count distinct of edge ID, I can see that I have 695,000 edges of type buys. So there are 695 relationship between products and customers. And then I have 55,500 relationship of type lives in. Because I have 55,500 customers, every customer live in a country, I have the same exact number of lives in because every customer lives in one country. As before, I can also count the properties that I have. In this case, it's really simple. The state province for the lives in and the amount, order date, and quantity for the buys. And there I am. After a bunch of unpivoting, after turning columns into rows, I have a graph. I mean, okay, I have just 6 database tables, 2 of them containing a bunch of data, 2 others automatically filled by a trigger. It's not really a fancy thing, it just looks like 4 tables. It's still not a graph, so let's do something with it. This graph, it's now time to do let's take the graph and load it into PGX. Get the graph into the property graph engine, and let's use the power of the engine. So I'm just again connecting to the system. I'm connecting to my Java virtual machine. I connect to PGX as a session. And then I will just execute everything and I go back because it will take some time. Okay, now it's started. So I connect to PGX. Here, session, create session. And then because I need to load from a database, security at Oracle said, we don't like to store password in configuration file and so on, so please use a key store. So I need to attach a key store to my session. Okay, I have to set the password of my key store in this place, but details, at least Oracle, we can say the password is not stored in a file, details. So how can I load a graph in PGX from a database? I need to create a graph config builder. So I need a graph configuration, and there is a builder object that helps me to build the graph configuration. The graph configuration, I take the one for RDBMS. There is one for flat files, there is one for NoSQL, there is one for various kinds. In this case, I want to load from a database, so I take the one from RDBMS. I set my username. So this is the username containing the graph in the database. It's my database schema. Key store alias, this one replaced it just replaced the password. Before it was just set password. Now the good practice is set a key store alias, so it's the alias inside my key store that contains the password. In this case, I just call it graph user directly. Set name, this is the name of the graph. I have to say which graph do I want to load. Here you can see that I don't have the $, $VT$ order. You just take the previous name and then the system will check and find out, is this one really a graph? So it will check, you can find the $, the $, and so on based on this name. Max number of connection 4 is just parallel task. So how many parallel queries I want to fire. JDBC URL, when I want to load from a database, I better tell the system where my database is. So this is just a JDBC URL to tell the system, here is my database, please. And then some properties, like set load edge label. I want to load the label for the edges, yes. I want to load the label for the vertices, yes. This is the date formats to expect when you load. And then I also say all the properties that I want to load. By default, the system will load edges and nodes without any single property. It's up to me to say, please load this set of properties. In this way, I can limit the amount of memory. If I have 10,000 properties on every single node, but I only need 4 for my job, for my queries, it's like doing a select star from a table or select column 1, column 2, column 3 from the table. It's the same thing. I just limit the amount of things I load. Because I'm lazy, all this part that is define all the properties, I don't have to write it by hand. It's a database, so I can do a query in SQL that generate me the piece of string that I need. So I extract all the properties from the vertices and the edges, and then I do a bunch of case one, list tag, and there I have a string that I copy paste into my config, generate all my properties. That's me being lazy. I could write it by hand, but I'm lazy. I mean, that's like developer, they like to copy paste more than write. And the config is just JSON. Here you can see just a full piece of JSON thing. This one, I could store it in a file and just point to that file, PGX will load my graph. So once I'm ready, I call session read graph with properties, and I say, and this is the configuration. This one now is my JSON that you can see here on above, or this one can be the file containing the JSON. And this one now it's still running. Oh, it just finished. That's Swiss timing, you see? I get there, I finish. What is my graph like? I have this name, number of nodes, 55,595. Number of edges, 695,133. Created snapshot time. Does my graph really have that? Let's query it. Number of edges, number of vertices. Yes, my graph really has all these things. Let's do a query. PGQL query. I have no time to explain you PGQL because this one will be 2 more hours of session. There is a website containing all the spec of PGQL. Keep it simple, it's SQL for graphs. So select, you all know how it works. Order by, limit, you all know how it works. The new piece is match. This one is really the graph part. If you look at it with the brackets and the pointing arrow, it really looks like a pattern. It's a customer node connected by a buys edge to a product node. So when you look at it, it looks like the query it's about to perform. So let's execute it. And if I'm lucky, here I am, I have 10 orders. So Abigail bought a quantity of 1 Envoy external 8, a CD-ROM 8 speed. Wow, that was awesome. $63, long time ago. So I can just do queries. My graph is there, it's ready. Now I can do more than queries. So let's just show something. So for this part of the job, I will just translate my graph result into a pandas data frame to do a little chart in Python. So I'm just cheating a bit. Let's say, give me the amount, the amount of sales and the amount of the total amount of quantity by product. So here in total, I sold a quantity of 12,837 deluxe mouse. And this is the total amount. So this is now just in pandas, so I can use it in Python. I can also do small charts. So I can see that by amount, the most sold object is Envoy Ambassador, followed by a LCD screen. By quantity, the most sold one was a mousepad, followed by a keyboard, wrist rest, and by a OS documentation set. Now let's do something more fancy because it's a graph. Let's just do a page rank analysis. I want to be Google. I want to do page rank. Page rank is a super useful and powerful algorithm that exists by default in PGX. So you just look at your graph and find out the object with the most connections. So it finds you the most, let's say, the most important piece of the graph. Because of the way that my graph is built, I expect it to be similar to the total quantity list. The higher page rank for me must be mousepad, followed by the keyboard wrist rest. And when I call my page rank function and then I query the result of it, I can see that I'm doing an order by descending. So the first one is my mousepad, the second one is the keyboard wrist rest, and so on. So here I'm doing graph analysis in a click. And executing this cell, it takes 1 second. It's thousands of objects. It's doing page rank, which is an advanced algorithm. It takes less than a second. That's the power of in-memory graph. PGX, that's what it's good at. Doing in-memory, super awesome and fancy and advanced calculation and works with algorithms. And then ideally at the end, I just clean up things. So I free the memory and I will not run the last one because with this one, I will drop my database tables because I say, please get rid of my graph. I don't need it anymore. Gone. I'm now 45 minutes in and here I am. I went from nothing to one graph in the database and load into PGX. Job done. Now there is a shortcut for all this part of the queries, all the unpivoting thing here that you saw at the beginning. There is something new that has been added in the last 2 releases, in the last few months. You could call a piece of PGQL that say create property graph, and here you decide, okay, use the SH customers table. The key is customer ID, the label is customer, properties are those one. Countries, call them country, and then these are the properties. So I called generate a graph via a PGQL query. And this one will do all the SQL job that I did by hand before is done automatically. So I just took the long way to get to the graph to clearly show you how you really build a graph and what your graph table, what your graph schema looks like. But there is a shortcut which is using this one here. So if you look at the pgql.lang.org website, you find all the documentation about this syntax, nothing really special. So I'm a few seconds over time, but let's go directly to my conclusion. First point, important, super important. Since December last year, property graph is free. It was a paid license before. Now, if you have a supported Oracle database, it's free. You can use it for free. No need to buy the special and graph license pack at all. You have your database, it's supported, go for graphs. If you want to find out more about the graph, this is the links to the documentation. They can really take you through an example of how to build the graph. They explain you all the details about graph. If you want to download PGX, there is the link as well. You can do all those things for free. Oracle Autonomous Database, they always free tier one they always free one that you can get. It support the storage of property graphs, so you can use it to store your property graph. You have no excuses. Don't tell me that you don't have a database. It's on the cloud, it's free. The most important thing, the property graph is not going to replace your relational database. It's not one instead of the other. It's the two together, because the graph gives you a different point of view of your data. It gives you a different aspect, a different palette of analysis. You can do analysis that you were not able to do easily in your database before. So it's just one and the other, they go together. And before to jump into the question, quick reminder, next week, almost the same time, join me if you want to have machine learning for graphs. This is some quite cool and fancy things. So join me next week if you want, or also later this month, there is a full graph day with 4 sessions by various people. Go on the Analytics and Data Summit website. It's fully free to attend, it's online, so feel free to join. And now let's see if I can find where I put the Q&A window. Okay, first question, when to use graph database and when not to use? I mean, you use it when you need it. That's the thing. The graph database, it's not there to replace something else. It's there to give you a different approach. When you focus on relationship between data, on the structure, a graph is more powerful than the relational database. When you have to find patterns, when you have to find dynamic or variable length pattern in your data, how you can connect things together with an undefined number of steps between objects, that's where the graph really gives you the most powerful approach. It's really not a replacement of your relational database, it's an extension, it complements it. From an analytical point of view, it's really a way to have different answers to different questions. It really extends the palette of topics that you can do and the things you can do in your data. So it's not one instead of the other, but it's all about, when you care about the structure of the information, the patterns, that's where a graph is good at. So does getting a graph database require separate license, or it comes by default with regular database? Since mid-December last year, it comes with regular database and no need of license. It's free, fully free. So really no excuses, use it, please. I mean, try at least. And can you have my presentation in PDF? Yes, you can. I guess I will give it to the organization team and they will make it available somewhere. Or you can also find it on my website. If not, ping me on Twitter or whatever. I will send you the PDF. No worries for that.